Welcome to the MS SQL Tips webcast, taking advantage of Azure's latest features for your next SQL Server deployment, sponsored by SIOS. I'm Greg Robidoux, co-founder of MS SQL Tips and the host for today's webcast. Our speaker today is Dave Birmingham, who is a Microsoft Clustering and Data Center MVP, and today he will discuss some of the new Azure features that can help your SQL Server deployments to Azure. During the webcast, we encourage you to ask questions. To ask a question, enter your question in the question area in your presentation controls. We will answer as many questions as possible during today's webcast. In addition to today's event, we invite you to check out all the free resources on mssqltips.com. If you're not already a member of the MS SQL Tips community, we invite you to join. You can go to www.mssqltips.com and sign up for our newsletter, read any of our tips, download white papers, and watch on-demand videos. This webcast will be recorded and archived for future playback, and you'll receive a follow-up email with links after today's event. So at this time, I'm going to turn things over to Dave, and he can get started.
Great, thanks, Greg. As Greg mentioned, my name is Dave Birmingham. I'm a Microsoft Cloud and Data Center MVP with the focus in high availability, disaster recovery, and cloud deployments, Azure, AWS, and whatnot. And then SQL Server is kind of the application I'm usually focused on as well. And in this webinar, what I hope to do is kind of review what has happened in Azure over the past 6 months or so that might impact your the SQL Server DBA that wants to run SQL Server in Azure infrastructure as a service. I'm not going to really touch on what's been going on the Azure SQL platform as a service. Lots of good stuff going on over there, but this is going to really focus on the infrastructure as a service and some new features that have come out that I think you should be aware of. And as you know, anything with the cloud, it moves at the speed of light. There's new features being introduced every day. They go from private preview to public preview to released products. So we're going to just talk about some of those features. At the end of the slide deck, I'm going to jump over into the Azure portal and show you some of these features as well. And this is not an exhaustive list of new features, but I think these are features that are interesting to me, and I think to any SQL DBA they would be interesting. So before we get started, cloud adoption I've seen in person in my work at SIOS Technology, the vast majority of our new opportunities is cloud deployments, and we see here that more than 70% of the Fortune 500 companies have at least 2 different Microsoft Cloud offerings, and more than 80% of the world's largest banks are Azure customers. And that's a quote that was just released here on January 11th over there in my privately budget. So before we get started, I kind of get a feel for what you're doing in the cloud and what you're using today, if anything. So Greg, if you want to pull up poll question number 1, we'll take a look at the cloud adoption.
All right, that's been launched. So everybody just take a couple seconds just to answer that question. Which cloud platform are you currently using? And once people have voted, we'll share the results. So give another, let's say 10-15 seconds for everybody to get an opportunity to vote here. Let's get those last couple votes in, and all right, I'm going to close that and share the results. So 47% said not currently in the cloud, 44% said Azure, 19% AWS, 10% other, and 3% Google.
All right, well that's good to know. So half of you or thereabouts are in the cloud, and typical spread between Azure and AWS. Now Google, we see, is definitely, I know Google recently has made some announcements around cloud and SQL Server specifically, so I think they're trying to gain a foothold in the marketplace as well, so it's good to see. Okay, so first feature is not necessarily cloud specific, but I thought it was too big to ignore, and it certainly has implications in the cloud. And that's Microsoft's announcement that SQL Server running on Linux is what they're coming out with, and they actually have the preview out now. And so Microsoft wants to offer SQL on running on Linux. And so, you know, when I first heard that, I was like, well, why would anyone want to do that, right? You know, if I'm running SQL Server, I'm typically a Windows guy anyway, so I'm going to run Windows. And, you know, talking to some people, I heard what you see here. So a lot of times, you know, the Linux is the operating system that's just in place in your enterprise. And typically, if you're running Linux and you want to use a database that's not, you know, open source, then you're looking at Oracle. And as we know, Oracle licensing and sales can be trying at the best. So Microsoft's hoping to give those people an option now that they can actually run SQL Server on their Linux deployments. And to do that, they're basically giving away SQL Server licenses as well as the support for anyone that is going to move their Oracle databases to SQL Server. And so there's some online information about that. If you're interested in that, moving over from, you know, Oracle to SQL, you should definitely check out the offer that Microsoft has now to make that move. The other reason I heard, I got some feedback on a blog post that I wrote is, you know, people are really interested in containers, and containers on Linux is a lot more mature than Microsoft containers, and so they might want to run SQL on Linux in containers. So that could be another reason why people are looking at SQL on Linux as well. But my question is, how likely are you to run SQL Server on Linux? So I'm really trying to get a feel for how big this is going to be. So, Greg, if you could put up poll question number 2, I'd like to see what the audience says.
All right, it's been launched.
And while that's running, you know, later at the end of the session, we'll have Tony Tamarchio from SIOS come on and give a little product demonstration that ties into this. He also wrote a blog post on his blog, linuxclustering.net, that shows you how to build he actually put together a SQL Server on Linux failover cluster. And so that's all documented on linuxclustering.net if you're interested in checking that out.
All right, and I'm going to close the poll, and I'll share the results. So we have 27% said very unlikely, 22% undecided, 22% likely, 21% unlikely, and 8% very likely.
All right. Well, that's I mean, that's a pretty decent percentage of people that are certainly considering it, or, you know, possibly deploying that. So it's good. I'm really curious to see how this takes off. So moving forward, next feature, and most of these features were announced at Microsoft Ignite back in September. And so we're talking about SQL Server deployments. A lot of deployments are hybrid cloud, where you might want to stretch your on-prem into Azure, and you know, for disaster recovery, or just to stretch your data center across multiple locations. And one of the features they announced was this thing called Active Vpn Gateway in Azure. So before the Active, what you had pictured here was kind of an active standby. So you had some redundancy should the primary VPN gateway fail, but failover to the standby would cause an outage and drop connections for, you know, sometimes up to a minute or so. And so what they came out with now is the ability to have an active VPN gateway, and that's going to give you much higher levels of availability when you're talking about your hybrid cloud solutions. And so pictures here is a typical fully mesh solution with, you know, active on-prem as well as in Azure. It's going to give you more redundancy, more reliability for your connection into Azure. And then the link to the documentation about this is right here in this slide. Next feature that I really love, because I'm constantly you know, spinning up new cloud instances just for lab purposes or demo purposes, and it's not production. Most of my work is in my lab, and and I'm trying to not burn through all my MSDN credits within the month. And sometimes I'm testing very large instance sizes with lots of premium storage, which can get pretty expensive pretty quickly if you forget to turn it off, which I've done. And I've learned, it can cost you quite a bit of money if you leave it going. So when you build a VM, and I'll show you this in a minute, you can actually enable the auto shutdown feature, and it's very simple to do. Just turn it on, tell what time you want to shut down, and that VM will automatically shut down once it gets to that point in time during the day. So that's going to save you from building up a lot of expenses unnecessarily. Next feature that was announced is something called Azure Advisor, which I think is really great. And what it does is, at a single kind of portal, you can get an overview of your Azure environment, and you can sort it and filter it by subscription or resource groups. And it's going to give you actionable recommendations across 4 categories: high availability, security, performance, and cost. And so this is a snapshot of an active environment that has some issues that you might want to take care of. And we'll take a look at this as well at the demo at the end. But so if you dig in a little bit deeper, so what it's looking at specifically under the cost, under the cost is underutilized VMs, and also diving more into the Azure Platform as a Service, the SQL Db elastic pool savings. So if you're familiar with elastic pools, it can help identify workloads that would benefit from using the elastic pools. Under the performance category, it really leverages the SQL Database Advisor for SQL Azure databases. So again, this is really more for your platform as a service, rather than at this point, looking at the infrastructure as a service virtual machines. It's geared towards that. In the high availability category, it's 3 very specific things it's looking for. It's going to point out machines that are not in an availability set. And if you're familiar with deploying highly available SQL Server, always on, or failover clustering, you know that those virtual machines need to be in an availability set to ensure they're distributed across different fault domains and different update domains, so that there's no single point of failure. So it will identify virtual machines not in an availability set. Same thing applies to domain controllers. If you have a couple domain controllers for redundancy, you want to make sure they're in availability set. Your front-end servers, your web servers, everything really that is important should be in an availability set. Of course, just because it's in an availability set doesn't mean it's highly available if there's only 1 VM in that availability set, so it also identifies those situations. And then this is something listed under high availability, and I'm not quite sure if it really falls in that category, but it will identify virtual machines with standard disk. And I really see that more as performance than availability. I'm not quite sure why Microsoft put it under that category. But of course, standard disks are fine, but with the premium storage, you're going to get better IOPS on the SSD type disk. But it will identify those virtual machines for you. And all these categories, as they identify these issues, they also give you quick links to actually address this issue. So you can click on the link, and it'll take you to tell you how to actually go ahead and address this issue. And for security, it integrates with the Azure Security Advisor, so it's going to be able to identify any security risk that the Azure Security Center would typically pull up. So that's integrated all under one Azure Advisor console. Next feature, which I love, is the Azure Storage Encryption. So when you talk about cloud deployments, encryption is security. Encryption is probably #1 on your mind. You want to make sure no one gains access to your data. You're putting it in the cloud and it's leaving your data center. So this new feature, Azure Storage Encryption, is kind of another option that you have in your tool belt when you're thinking about protecting your SQL Server databases. And listed here are the typical options you have when you're thinking about encrypting SQL Server in Azure, or even on-prem in some cases. So of course, with your SQL Server Enterprise Edition, you have the Transparent Data Encryption, or TDE, as an option, and that's going to encrypt, at the SQL layer itself. And then in Azure, you can enable Azure Disk Encryption. So as you provision a disk, you can encrypt that disk specifically, and that leverages BitLocker, which you're probably familiar with, is available on-prem as well. But that's integrated through Azure. So the new feature, Azure Storage Encryption, it encrypts the data on the back end, and I'll show you an example of how that works. But it's very simple. When you create a storage account, you can just check a box, say encrypt this storage account. And what I like about this is there's no additional overhead on the host that is writing to that storage. And I've tested this to verify that there's no additional overhead whatsoever. And so if you check the box, all new writes, and that's the key right here. So anything that was on that storage account before you turn on the encryption is not encrypted, versus Azure Disk Encryption. If you turn it on, it will encrypt the entire disk, including everything that was already written on it. But assuming that you create the storage account before you create your virtual machines and your databases and whatnot, anything written after you enable storage encryption will be encrypted very easily and without any additional overhead. So I'm really excited about the Azure Storage Encryption feature. This is a picture. I'll show you in the demo here. It's simple. Just enable it, and that's it. So I'm curious as to what your preferred encryption method today is for SQL Server. And so Greg, if you want to pull up poll number 3, we'll take a look at that. And see what people are doing.
All right, let people give another 15, 20 seconds here. I'll close this out and I'll show the results. All right, another 10 seconds. I'll wrap this one up. All right. So we have 39% said none, 36% said TDE, 11% storage encryption, 9% disk encryption, and 5% other.
Okay, that's good to know. I'm glad to see some people are already using the storage encryption, and of course disk encryption is there. And TDE, if you have the Enterprise Edition, is always a good option. So that's good to know. Next feature, again, this was all announced back at Ignite, is something called accelerated networking. And what pictured here is a network without accelerated networking on the left, and then with the accelerated networking on the right. And as you can see, basically, with the accelerated networking, your VM is going direct to the physical network interface card and the physical switch and bypassing the virtual switch completely. And Microsoft claims some really extraordinary gains in ability of network throughput by enabling this. And what I found is that you actually can, they're advertising, I think, 25 gigabits per second with accelerated networking as a possibility. And what I found is very true. without the accelerated networking enabled, and this goes across most instance sizes, you have about 3 gigabits per second. Now, Microsoft currently does not advertise or promise any sort of network speed between instances. They'll have kind of a low, medium, high type setting, and I did some testing on my own and found that low was about 750 megabits per second, medium was about 1.5 gigabits per second, and then the high speeds were around this 3 gigabits per second. And none of that's guaranteed, and depending upon the time of day and I guess what else is going on in that network, you're going to get speeds slightly above or below at any given time. But with the accelerated networking enabled, I could achieve over 30 gigabits per second. So you can imagine if you have that much bandwidth available, how much better your applications are going to perform communicating with SQL Server. Or if you're doing replication between instances, you have so much more bandwidth available as well. So accelerated networking even is going to have benefits because the storage is connected through the network as well. So you're going to have even better performance on the storage, writing and reading from the storage with decreased latency as well. So this is all in preview, but keep your eyes out on that, because once this is available across all instance sizes and regions, you're definitely going to want to enable accelerated networking for your SQL Server instances. The next feature that they mentioned is virtual network peering. And so this is kind of pictured here, where before you really couldn't communicate if you had a virtual network, virtual machines in virtual network A, they couldn't communicate directly with a virtual machine in virtual network B. You had to go through a gateway with the latency involved with that. So what they do now is you can actually create peers between 2 virtual networks so that the instances can communicate directly between virtual networks. And I think the best use case for this, the reason that you might be forced to do this, obviously if you plan properly, most of your stuff should be in the same virtual network, but early adopters in Azure might have used Azure Classic resources and have a whole virtual network based on that Azure Classic model, which is fine, but all the new development is being done in Azure Resource Manager. And so you're deploying new instances in a different virtual network using ARM or Azure Resource Manager. Now, those instances between Classic and Resource Manager can communicate directly with each other, so they can coexist until you're able to, obviously I would think you would want to migrate your resources all to the ARM model over time. But until you get to that point, using the virtual network peering, they can coexist very nicely together. And the final feature I want to talk about before we jump into a quick demo here is multiple VIPs on ILB endpoints. And so this was announced at Ignite, and I was really excited about this because this was one of the pictures that was included as part of the announcement, was the ability to have multiple availability groups deployed in a SQL cluster with multiple availability group listeners. If you follow along, if you've tried to deploy a SQL Server always-on availability group in Azure, you probably realize that up to now you were limited to a single availability group listener due to a limitation in the Azure internal load balancer. And if you don't know what I'm talking about, I'll quickly review. Clusters and always-on availability groups in Azure require a little bit different handling than you're used to with your on-prem availability groups. And the problem lies in the Azure networking stack not supporting gratuitous ARPs. So your clients cannot communicate directly to a client access point. So typically a cluster resource will have a name and a virtual IP address that moves between instances. In the availability group, each availability group has that client access point and that client listener, so you can have multiple client listeners, and so you can have some availability groups running on VM1 and some on VM2, and that helps you bounce your load and gives you more flexibility in your deployments with multiple availability groups. Well, in Azure, you can't communicate directly with that IP address because your traffic doesn't route directly to it. So what you have to do instead is create an internal load balancer, and the clients connect to the load balancer, and then the load balancer redirects the traffic to the internal address of whichever node is online. Up until recently, you could only have one IP address per load balancer. That limited you to a single client listener for availability groups, and also for failover cluster instances, you could only have one virtual IP address per cluster. So if you were building a SQL Server failover cluster with multiple SQL instances, you couldn't do that in Azure. Now, a few weeks ago, I published a blog article illustrating how to create multiple SQL Server instances in Azure and have all the steps to create the load balancer to redirect the clients to the instances. And so you can check that out at clusteringformeremortals.com. And so I went about the process of trying to do this with availability groups as well. And while I thought I had it nailed, I've been reviewing my my lab, and it's not quite working the way that I expect it to work. So I don't have all the specific details that I can guarantee are going to work, but I'm going to show you the internal load balancer and the new features, how to add additional virtual IP addresses on those, and then I hopefully will be able to follow up with a blog post with all the details on how to configure this. Microsoft themselves have not documented this feature yet, so there is a chance that it's not quite functional yet, so keep your eyes peeled. I'm going to be looking into this over the next week to try to get to the bottom of it, but I'll show you where we're at today. But I did get this to work with multiple SQL Server failover cluster instances. And that step-by-step article I mentioned is in clusteringformeremortals.com. Back in December 29th, I published that. So let me jump over to demonstrate some of this. So we're going to look at some of these in order we went through. So again, auto shutdown I think is it's great if you're building labs. You're definitely going to want to take advantage of that, and that's very simple, simple to turn on or off. So here are all my virtual machines. They're currently all running, and each virtual machine will just have a simple feature, auto shutdown, and you can enable it. So you can turn it on. You can tell what time to shut down, and you can even get a notification if you want to be notified before it's shut down. So let me save that feature. That's good. So it's simple, very simple. Azure Advisor, I'll show you what that looks like. Advisor, you can search for it if you can't find it. Your Azure Advisor. Again, this is all preview. Azure Advisor is in preview, but it looks like this. And again, with my you click on Gate Recommendations, it goes and kind of looks at all this stuff. And you see it has some high and medium recommendations, one for high availability, one for security, and it's still refreshing those. So this is very simple. We can click on, see what this is, security, jump over here, advanced security for subscription, and you click on that. Standard tier adds advanced threat detection. Advanced threat protection, right? So I can enable advanced threat protection. So it wants me to sign up for that. So that's Azure Security Advisor. It's a very simple portal interface that is going to give you some great advice on that. Jumping over to Azure Storage Encryption. Again, one of my favorite features because it's so simple and it's so nice. So I click on any storage account I have enabled or provisioned here, and within the storage account, what comes up here, we have encryption. If you go down here, encryption, and you just turn it on, save it, and now anything written from this point on is encrypted, and that's key here. It doesn't go back and encrypt anything that's currently on that, so you need to be aware of that. But if you create your storage account before you start creating your instances, then everything is going to be encrypted for you automatically with no additional overhead. And the last feature I want to demonstrate is the multiple VIPs. So I'm going to go through the process I did earlier with my SQL Server Failover cluster instance and show you where the differences are. So there's new features in the load balancer. So let me open up my load balancer. Here's my SQL load balancer. Again, I was doing some testing earlier with some availability groups, so there's going to be some things in here. But the big new feature that wasn't here before, if you in your load balancer, if you click on front end IP pool, where before each load balancer could only support a single IP address, you see now I can have multiple IP addresses. So what I did is I created, when I built the Failover cluster instance, I created I added the virtual IP address into the front end pool. So maybe the .10 would be the address I added, right? So that was new. And then in the back end, I created a new back end that I'm going to use for when I create my load balancing rule. So in this case, my backend really contains the same instances, my two instances in the particular cluster, SQL-0, SQL-1. So I have two backend pools, one for each instance of SQL. And then same with health probes. So again, I'm assuming that you might know a little bit about this if you tried to implement failover clustering or availability groups before in Azure. This is all very well documented for a single availability group or a single failover cluster instance, but where the documentation is lacking is what I'm showing you now and how to add additional instances. So with a single instance, you would only have one health probe, and basically the probe, by default, if you follow the instructions for a single instance, it probes port 59999. So I have that health probe set up. That's kind of the default health probe. And then as I add additional availability groups, I have to add another probe because availability groups could be running on different nodes. So you need to know which node is alive, and that's what this health probe does. So I created another probe for port 59997 and for AG2, and then another probe 59998 for AG1. So you have to create the health probes for each instance that you want to put in your cluster. And then it comes down to the load balancing rules. And so for the availability group demo I was working on, I had created the default rule was this one, the SQL Server endpoint, and we see that it's using the front end pool that we specified that's going to be associated with the first availability group, the .9, but all my other addresses that are in the front end pool are listed here. So .9 is fine, and port 1433 is the default port that SQL, the availability group's listening on. So the first one is fine, leave that 1433. We chose the backend pool that had those virtual machines. You see the different backend pools available. And then associate that health probe with that particular node, the port 59999. And the important thing is the floating IP or direct server return should be enabled. So that all works fine. And as you add additional rules, you can see I added a rule for AG1. It uses the second IP address, and that's associated with that availability group listener. The port has to be unique. So when I went into the SQL Server, I changed the port number to be 1440. Same thing if you have a named instance. If you're doing a failover cluster instance, you have to lock down that named instance to a specific port, and then specify that port here, and choose the right backend pool that has those virtual machines, and then choose the right health probe that's going to probe that particular instance. And again, the direct server return is enabled. So once you have that all configured, on the other side, again, if you've done any work with this before with a single availability group, you know there's some work that needs to be done on the cluster itself. So, and this is all pretty well documented. In order for the cluster to accept those probes, you have to run a PowerShell script that is going to listen for that particular probe. So in this case, I was updating the IP resource for the AG2 that's probed on 5997. So again, this is all in the documentation. You have to run this so that the actual IP address is listening for that probe. Once you do all that, the application should redirect to whichever node is active. Now again, I got this working with failover cluster instances. I thought it was close with availability groups, but I'm having some issues. So I don't want to give you wrong information quite yet, so keep your eye out for a blog post. Once I figure out what's going on, you should have some information on that. So that's a quick overview of some of the new features, and I'm going to turn it over now to Tony Tamarchio from SIOS Technology, who's going to talk about the SANless clustering with Datakeeper.
Excellent. Thanks very much, Dave, and great overview on some of the new features that are now available in Azure. So let me go ahead and share out my screen. Yeah, so definitely the internal load balancer feature to support multiple virtual IPs is I agree, is definitely very exciting because it allows you to take advantage of your resources more effectively up in Azure and not just have nodes sitting there idly because you can only run a single availability group or a single failover cluster instance. So that's very exciting news. So what I'm going to take you all through here today is one way that you can deploy a failover cluster instance of SQL Server up in Azure. So as Dave mentioned, they've got a lot of different options when it comes to SQL Server availability. One of which is availability groups, which one of the benefits of that is it allows you to deploy things when there isn't shared disk because it's basically doing SQL level replication. So it's synchronizing the data between the different nodes. However, there are a number of limitations that you need to be aware of when if you're going down that route. For example, it generally requires the enterprise edition of SQL Server. So if you've been used to running on standard edition and now you want this to be highly available, that can significantly increase your costs. As opposed to a failover cluster instance, you can do a 2-node failover cluster instance with SQL Standard Edition. Additionally, availability groups, it doesn't protect the full instance, so it's only replicating and protecting your user databases. So things like your system databases, master, MSDB, or SQL logons or SQL agent jobs, you're still going to have to manage those separately. So with a failover cluster instance, you get full instance level protection. Now, one of the challenges in deploying a failover cluster instance in the cloud is that typically it requires shared storage, and in Azure and most other cloud and virtual environments, you don't have access to shared disk between the different systems. So here at SIOS, we have a solution called Datakeeper Cluster Edition, and it's a software solution that installs on your Windows cluster nodes, and it does real-time block-level data replication, and it's cluster aware and cluster integrated so that it allows you to deploy a Windows Server failover cluster, and the cluster thinks that it has shared disk. And I'm going to show you what that looks like here in just a moment. This can not only be used for SQL high availability, but really for any other workload that you want to place into your cluster here. So, so here, I'll take you through a quick demo. I've got a typical cluster, 2-node cluster. My cluster nodes are called SIOS 1 and SIOS 2. And these are 2 virtual machines. There's no shared storage whatsoever. So what you're going to notice are 2 differences from a typical cluster if you've set one up in the past yourself. 99% of this is going to be the same. So first is with the witness. If you were doing a typical on-prem shared disk failover cluster, you'd have a disk witness, or a quorum disk as it used to be called. But up in the cloud where there isn't any shared storage, you can't do that. So here you would use a file share witness instead. The second difference is with the storage. So again, I don't have any shared storage between these systems here. So what Datakeeper is providing are these Datakeeper volume resources for the various drive letters that you choose to replicate and protect and have part of your failover cluster here. So this is what Microsoft would call a third-party storage class resource. So I've got a couple of these already in my cluster, and I'm going to show you how you can create one in the demonstration here today. So let's take a look here. I have a clustered instance of SQL Server, so a failover cluster instance. So again, the beauty of this is, it's compatible with all applications. I've got full instance level protection. All the benefits that you're used to with a failover cluster instance. And with Datakeeper, we've now eliminated that shared disk requirement, so I can deploy this up in Azure. So this should all look very familiar for those of you who have set up a SQL failover cluster instance in the past. I've got my name and my IP, and as Dave mentioned, up in Azure, you've got to throw an internal load balancer in front of the cluster so that you can connect into this IP. And then you've got your SQL resources. Now the difference is with the storage resource. So instead of the shared disk, or also known as the physical disk resource, which we don't have in this type of environment, this is where we have the Datakeeper resource. So here I have this Datakeeper volume S storage resource, and it looks and feels and acts like shared storage. But in reality, I have these 2 virtual machines. They have matching drive letters and sizes. They have their own independent storage, and Datakeeper is synchronizing the data in those drive letters at the block level, so it's completely transparent to the application. It's just writing to the S drive like it normally does, and under the covers, that data is being replicated continuously in real time. And both synchronous and asynchronous replication modes are supported, so you can select the one that makes most sense based on your recovery point objectives and your business requirements here. Now the way that these Datakeeper volume resources got into the cluster was through the Datakeeper user interface. It's a simple MMC snap-in. And what I'm looking at here is an overview screen where I can see here's my 2 nodes, SIOS 1 and SIOS 2. I do have a couple of drive letters that are already being mirrored here, and we'll create a new one. I'm going to replicate this R drive. So it's a simple 3-step wizard. You just go here and give it a name, call it R drive, and create a job. And it's a 3-step wizard, so you pick your source, then your target, and finally your mirror options. So my source will be node 1. I can select the drive letter that I want to use, and if you have multiple network interfaces, you can decide which IP to use as the endpoint for your mirror. Step 2, select your target. Nothing to change here. It's automatically selected the other node, the right IP, and the matching drive letter. So nothing to change on step 2. And then finally on step 3, I can select my mirror options if I want to enable compression or throttling. And probably most importantly, you can select your replication mode. Here I'm going to put this into synchronous mode. These systems are all in the same region, so they're all connected with a high-speed, low-latency network connection. So I go with synchronous replication so that for maximum data protection here. So this takes just a moment to create the mirror, and because Datakeeper is cluster aware, it's now asking if I want to register this as a cluster disk. So I'm going to go ahead and say yes. And now that that's done, if I can see I've got this brand new Datakeeper volume R job, node 1 is the source, node 2 is the target. I can click on the job and look at information, just kind of view this a different way. But if I go back into the cluster, well, right now I have this brand new Datakeeper volume R resource sitting there in the cluster's available storage pool. And at this point, you use it like you would any other shared disk if you were doing this on-prem. So that's the beauty of this is, for any of you who have set up a Windows or a SQL cluster in the past, 99% of how to do all of this. It's just an additional 3-step wizard to create the Datakeeper mirrored disk resource and have it dumped into the cluster here. And from this point, you just add your Datakeeper volume to a cluster role, or you install your next instance of SQL Server into the cluster, and in the cluster disk selection screen, you just check the box next to Datakeeper volume R. So really, that's all there is to it here. So some of the key benefits here, it allows you to achieve full SQL high availability, full instance level protection. You can do this with SQL Standard Edition. You don't have to make the jump to Enterprise. It's compatible with all applications, and it also lowers your administrative overhead because you're only having to manage one clustered instance of SQL Server as opposed to availability groups where you basically have 2 standalone instances of SQL, and you have to remember when you make changes to one, you have to make the same change to the other one as well. So a lot less to worry about and administer on an ongoing basis. So with that, let me go ahead and stop showing my screen here. And I guess Dave, I'll turn it back to you. Dave and Greg, I'll turn it back over to you, and we can go through next steps and Q&A.
Yeah, great. Thanks, Tony. So I guess at this point we'll open it up to really kind of any questions you have. I know we covered a lot of material. I'm not claiming to be an expert on every new feature, but if you have questions, I'd be glad to hear them. Or if you have questions for Tony, really anything cloud related, high availability related, SQL Server, clustering related, floor is open. And we'll stay here till the top of the hour if there's questions that long. Otherwise, we'll wrap it up and give you the rest of your day to yourself. So use the interface to submit your questions. And Greg, if you as you see questions come in, if you want to feed them to me, we'll do our best to address them.
All right. So the first question is this is just a general moving to the cloud question, whether it be to AWS or Azure. So we're just wondering, once things get moved to the cloud, either as infrastructure as a service or platform as a service, as you mentioned, what's the role of the typical DBA today? Do they still have a role in this, or does everything just kind of get handed over to something up on the cloud that's managing their database platform now?
Yeah, certainly the DBA still has a role. In the cloud, you're going to have to still manage, well, especially, infrastructure as a service is really you're just running your SQL Server instance on someone else's hardware. So it's not a lot different than what you do today. Now, if you're doing platform as a service, then definitely there's still a role for you, but you're going to have to learn some new skills and learn a new technology, whether it's SQL, Azure, database, or AWS, I think has a platform as a service based, I'm pretty sure on MySQL. So, but we still need those DBAs to make the magic happen. So you still have a very active role. There's a new role though for anyone looking to accelerate your career or just move into new opportunities as I don't know the exact title, but I have cloud architects. I'm talking to a lot of cloud architects recently, and as you can imagine, there's not people with 10 years experience in cloud architecture, right? So if you see someone with 10 years experience, they fluff their resume a little bit. But trying to keep up with the cloud is a challenge because it changes so rapidly. But at some point, you got to put your toe in the water and jump in and see about maybe adding that knowledge to your resume, that experience to your resume, because there's going to be I think a big demand for good cloud architects that know how to not only migrate to the cloud, but implement the cloud and take advantage of all the cloud has to offer. If you're simply just recreating what you have on-prem in the cloud, that's okay, but I think you're missing some of the benefits of the cloud in the platform as a service, or even the software as a service in some cases. So it's good to familiarize yourself with the cloud offerings so you can kind of expand your horizons and job opportunities.
All right, great. Thanks, Dave. Actually, before we go to the next question, I'm just going to pop up a last poll question here, and it's just about if anybody's interested in learning more about some of the things that were discussed today. So I'll just leave it up there as we ask the next question. So Tony, this question's for you. They're just wondering, with Datakeeper, is it possible to have one node on-premise and a second node in Azure?
Yes, most definitely. So Datakeeper is just a software solution, so it's hardware and storage agnostic. So you most certainly could mix and match. You could have a mix of physical, virtual, and cloud systems. What's important when you're doing this is a couple of things. If you're doing this from on-prem to cloud, first of all, taking a look at the rate of change of your data and compare that to the network connection you have between your site and the cloud, and you want to make sure that there's enough bandwidth because Datakeeper is doing real-time replication, so it's going to try to push that data from source to target as quickly as it gets written on the source. So understanding your rate of change versus your bandwidth is key, and then basically your drive letters and sizes need to match. Aside from that, Datakeeper doesn't care if it's physical, virtual, or cloud, or a mix. So that's most definitely supported.
All right, another question for you, Dave, is just related to the auto shutdown feature in Azure that you mentioned. And so I'm just wondering if SQL Server is currently running and there's a transaction running, and so I guess how does the auto shutdown happen? And if it does happen, does it roll back that transaction, or do you know anything about how that actually works?
Yeah, I mean, I don't know specifically in that scenario. I'm guessing that it's going to behave the same as if you were, you went up to a virtual machine and went to start shutdown and initiate the shutdown process. I'm not 100% sure what happens, what SQL Server does in that instance, but waits for the transactions to be committed or not. I don't think it does a hard power off, but that's a good question that I don't know if I have an answer for you. So that'll be something to check out. But typically, I'm only doing that shutdown in my lab, because like I said, if it's important and you don't want to lose transactions, you probably want that up and running, and you want to have a little bit more control over when that instance is shut down. So that that's something you would definitely have to check out.
Okay, another question here is related to the high availability features, and somebody's just wondering how many 9s of availability will they actually get moving to Azure? Is there any?
That's a great question. Yeah, so Azure has SLA, and if you really dig through the SLA, they'll say 99.95% availability for any instance that's in an availability set when you have 2 or more instances. So we talked earlier about availability sets, and if you put an instance or multiple instances in an availability set, it distributes those instances across different parts of the Azure infrastructure so that there's no single point of failure, so different rack of servers. And so basically what they guarantee, they're giving you dial tone to one of those instances if it's in an availability set. That does not, however, guarantee SQL Server is up and running, and it also doesn't even guarantee that additional storage that's attached to that instance is up and running. Now, storage itself has its own set of SLAs. So if you check out the SLAs for storage, there's a lot of different, are you talking about reads and writes? Is it geo-redundant, local redundant? But when it comes down to it, the weakest link of the chain in storage is that the best SLA that they will give you for write operations on any storage is 99.9%. availability. And so if you are running SQL Server, obviously you want to be able to write to the storage. So I say that, Microsoft for your SQL Server deployments is giving you 99.9% availability of the virtual machine and the storage. Now when it comes down to the application, you have to take initiative to provide some sort of clustering or application availability. So whether it be a failover cluster instance or SQL Server with Datakeeper, or your always-on availability groups, which now with SQL 2016 has database level monitoring as well that gives you availability at that layer. So the only thing that Microsoft's guaranteeing is 99.9%. The rest of it is on you to manage and maintain.
Okay. And actually a follow-up question to that, I'm not sure, maybe Tony, you could take this one, or Dave. So I'm just wondering, with all these things that are up in the cloud, is there still a need to do clustering? And
yeah, well, just what I just said, if you think that you're going to deploy a single instance of SQL on a single VM and put it in Azure and say my job is done, you're just guaranteed that you're going to have downtime, because one thing that happens on a regular basis is scheduled maintenance. So we talk about availability sets, and I mentioned fault domains. I also mentioned update domains. And what Microsoft does is, fault domains, for each availability set, there are up to 3 fault domains. So it will spread, put SQL instance 1 in fault domain 0, SQL instance 2 in fault domain 1, and then maybe your file share witness in fault domain 2, to ensure that you only lose 1 vote of your cluster at any given time. But besides fault domains, it also distributes your nodes across update domains. And so you think of fault domains as racks of servers, if you're picturing it. So there's 3 racks of servers. And in each rack, there's multiple physical servers. And an update domain represents one of those physical servers. So each physical server will have a handful of virtual machines running on it. So when Microsoft does planned maintenance, it will only reboot one of those physical servers at any given time. And it doesn't do any sort of live migration. It doesn't move all those virtual machines off that physical server either. So you can be sure that Microsoft at some point in time is going to reboot that physical machine hosting your virtual machines, causing it to have downtime. So long story short is, yes, you still need clustering or some sort of availability in the cloud. Now, talking about infrastructure as a service, you're doing platform as a service. Well, that's one of the benefits of platform as a service is Microsoft manages the platform, and so it's on them. They have to maintain it, whether that's good or bad. I mean, you're putting your trust and faith in Microsoft and their resources and their expertise to maintain the availability of that. But that's one of the benefits, is you don't have to manage the platform. Microsoft does that for you.
Okay. All right. The next question here just related to, can you discuss some of the pitfalls of moving to the cloud, or things to be aware of to sort of have a successful implementation in the cloud?
Some of the pitfalls. I'd say, making sure that you know about performance that you can expect in Azure, right? There's a lot of things that could be potential bottlenecks. So from the instance size to the storage you provision to the network speed between the instances. So I have people who have deployed, a DS3 instance and a whole gob of premium storage put in, and availability, a storage pool striped for performance, and they're not getting the IOPS they thought they should with the amount of premium storage they added. And it comes down to it, the instance size itself has a published threshold of how many IOPS or how much throughput that particular instance will support. And it's an artificial number. Microsoft basically scales it back for that particular instance size. So performance optimization, you got to be aware of where the limitations are. Availability, we've talked about. Security is always a big concern. So there's, people mentioned there's still a need for DBAs. Yeah, there's still a need for DBAs. There's still a need for your security admins, because it's a whole new paradigm of, security in the cloud. They're no longer Cisco, experts, firewall experts. Now they're figuring out what tools and techniques they can utilize in the cloud to ensure that their cloud instances are secure. So you really need your whole team on board, just like you have, networking professionals, security professionals, DBAs, infrastructure managers, storage guys. You need all those people on board in your cloud deployment to have a successful deployment in the cloud.
All right, great. Thanks, Dave. We're actually out of time. We're going to wrap things up. So just want to thank Dave for sharing a lot of great information and Tony for sharing the information about SIOS Datakeeper. In addition, I want to thank SIOS for sponsoring today's event. The webcast was recorded, and you will receive a follow-up email with links to view the archive. Also, please visit mssqltips.com to access all of our free SQL Server resources. Once again, I'm Greg Robidoux from MS SQL Tips. Thank you for attending, and have a great day.